Vanakkam one and all. We will discuss problem number 10 of exercise 5.2. Here they are asking us to prove the function actually which is a greatest integer function where the value of x is in the interval 0 to 3 in the open interval is not defined, it's not differentiable at x equal to 1 and x equal to 2, which means to prove this one we have to say the left hand derivative and right hand derivative at 1 are not equal. Okay, so now we will calculate the functional value f of 1. When the value of x is 1, the functional value will be 1 because it is a greatest integer function. In greatest integer functions, for all input integers we will get the same integers as output as image. If the numbers are not integers, we will get some values. Okay, now here we have found the functional value of x, function value of x equal to 1. Now we will calculate left hand derivative. In the left hand derivative, in the left hand neighborhood, elements will be 1 minus h, where h is a small positive real number, and we'll get its derivative form by derivative f dash of 1 equal to limit h tends to 0 f of 1 minus h minus f of 1 divided by minus h. This is the definition of for left hand derivative. Now we will replace h x as 1 minus h over the expression. So limit h tends to 0 1 minus h minus 1 divided by minus h. Again by the definition 1 minus h, which means 1 minus h, h is a small positive real number. Suppose we are subtracting 0.005 like that, the result will be a small number which is closer to 1. So the greatest integer lesser to that value will be 0, because when the values of x are in the interval 0 to 1 will have their greatest integer function as 1. Suppose 0.9, its value will be 0. Suppose 1.2, its value will be 1 according to the definition of greatest integer function. So we will get 0 here minus, here we got 1 as greatest integer function of 1 as 1 divided by minus h. So we will get limit h tends to 0 1 by h. After substituting h as 0 over the expression, we will get 1 by 0, which is infinity. So the left hand derivative does not exist. So we don't have to speak about right hand. It is not necessary to speak about right hand derivative, but still we can calculate right hand derivative. So f dash of 1 will be limit h tends to 0 f of 1 plus h. In the left hand neighborhood, elements will be 1 plus h minus f of 1 divided by minus h, sorry, plus h. So limit h tends to 0 1 plus h, which means it's a number exceeds 1, minus 1. So limit h tends to 0, we will get 1 minus 1 divided by h, 0 by h. So 0 into h will be, okay, if this term is 0. Okay, so we can say the function is not defined, I mean 0. So right hand derivative is not equal to left hand derivative. We got it like this. Okay, so the left hand derivative and right hand derivative are not equal. We can say the function is not differentiable at x equal to 1. Let us check the differentiability at x equal to 2. So f of 2 will be 2. So f dash of 2 is equal to limit h tends to 0 f of 2 minus h minus f of 2 divided by minus h. So limit h tends to 0, 2 minus h minus 2 divided by minus h. So 2 minus h means it's a number less than 2. So by the definition of greatest integer function, the value will be 1. So 1 minus 2 divided by minus h. So we will have minus 1 by h, limit h tends to 0. So it will be infinity. Minus minus gets cancelled, we will get infinity. And here it does not exist. Now let's calculate the right hand derivative. Right hand derivative for that, f dash of 2 equal to limit h tends to 0, f of 2 plus h minus f of 2 divided by h. So we will have limit h tends to 0. 2 plus h means a number greater than 2. So by the definition of greatest integer function, the value will be 2. So it is 0 by h. It is going to be 0. So here right hand derivative is not equal to left hand derivative. It says the function is not differentiable. Hence we proved the function is not differentiable at x equal to 1 and x equal to 2. Thank you.